In this video, we will discuss linear inequalities in one variable. So we have 4 examples that we're going to complete, and for each of these we're going to solve the linear inequality. We will then graph the solution set on a number line, and then we're going to write the solution using interval notation. So for these, you can see that instead of an equation, we have an inequality, and that is shown because we have some kind of inequality symbol. In this first case, that's a less than symbol. In number 2, we have a greater than or equal to. In number 3, we have a greater than. And in number 4, we have a less than or equal to. So all of those are examples of inequality symbols. And so what that means is the left-hand side of the inequality has a certain relationship with the right-hand side. It's just not equal. So in number 1, x minus 2 is less than 5. So to solve that, we're going to get the x by itself. So to undo that minus 2, we can add 2 to both sides, and that will give us x is less than 7. That's our solution. So we've solved the linear inequality, so that's the first step. And then the second step is to graph that. So we want to draw a number line. We put our important point or our boundary point on the line. So this 7 is the number that I'm going to use because that's what I have. X is less than 7. And this actually separates our numbers that are solutions from our numbers that are not solutions. So this says x is less than 7. So that means everything to the left on the number line, those are all numbers that are less than 7. And all the way to 7. So I've got to make sure I don't have the little red on that side. So all the way up to 7. Now since it's not or equal to, 7 itself is not a solution. But everything right up until 7 is part of the solution set. So that's our graph. And then the last thing we want to do is write the solution set using interval notation. Interval notation is always the leftmost value to the rightmost value. Left number to the right number, smallest to largest. So that's how you write your interval notation. If you're looking at the graph, your smaller number is going to be the one that's all the way to the left. So it goes forever to the left. So that's negative infinity. And then it goes to 7. 7 is the farthest it goes to the right. Since it does not have an or equal to, we use parentheses. So parentheses indicate that the end point is not part of the solution set. For negative infinity, you can't actually get to negative infinity. It just keeps going. So that's why it always has a parentheses for the infinity or negative infinity. And so those are the 3 things that we needed. We solved. So let's see, we solved. We graphed. And we wrote an interval notation. So for any inequality, you should be able to do any of those 3 things. And it might not ask you to do all 3 things for every problem, but you should be able to provide any of those. So you should be able to provide your solution in any of those formats when asked. So for these 4 examples, I'm going to give all 3 formats just for practice. So number 2, same thing, we want to get that x by itself. So we would start by undoing the addition or subtraction. So add 2 to both sides. We would get negative 5x is greater than or equal to 11. Divide by negative 5. And we will see that x, okay, now here is a trick right here. If you multiply or divide by a negative, you have to change your inequality symbol. So instead of a greater than, which is what we started with, it's going to switch to a less than, and that's because we divided by a negative 5. So you're going to flip the inequality when you multiply or divide by a negative. So that's the case there. If you want an example to show why, let's say I have the inequality, let's say I have the inequality 1, and actually let me use a negative. Let's say I want to compare negative 2 to 4. Hopefully we can agree that negative 2 is less than 4. That's a true statement. Negative 2 is smaller than 4. Just like in an equation, I can multiply both sides by the same value. So I can multiply both sides by negative 1. And when I do that, I would see that I get negative 1 times negative 2 is now positive 2. And 4 times a negative 1 is a negative 4. If I simply bring my inequality symbol down, I will see that this is no longer a true statement. 2 is not less than negative 4. So when I multiply by a negative, I change the relationship between the two sides, right? The relationship is now the opposite. I was multiplying by a negative. So you always flip the inequality symbol when you multiply or divide by a negative because it changes the relationship between the two sides. So that's what we did in number 2. So we've solved, we get x is less than or equal to negative 11/5. The next thing we want to do is graph. So we're going to draw our number line. We're going to put our boundary here. So negative 11/5 is our boundary. Since it's an x is less than or equal to negative 11/5, that means that the boundary is an answer as well. So negative 11/5 is an answer. To represent that on the graph, we can use a bracket. We shade everything to the left because it's less than, and that's our graph. So for the interval notation, the leftmost point, it goes forever, so negative infinity. And the rightmost point, it goes is to a negative 11/5 with a bracket. So again, the bracket is associated with the or equal to. So let's make a little note. So if you have less than or equal to, or greater than or equal to, you use a bracket in whichever direction is appropriate. If you have a less than or a greater than, you use a parentheses. And again, whichever direction is appropriate. Some people also sometimes use a closed circle or an open circle on their graph rather than a parentheses or a bracket, and that's fine. You can use that if you'd like. Okay, let's look at number 3. Number 3 and 4, same directions. So first we want to solve. So to solve, we're going to first have to undo the parentheses here. So we're going to distribute. So negative 2x minus 2 is greater than 5x minus 8. And now we can bring the x's to the left, so minus 5x. And at the same time, I can bring the constants to the right, so add 2. So that is going to give us negative 7x is greater than negative 6. And so now I can divide by negative 7. Again, since I'm dividing by a negative, it's going to flip the inequality symbol. So I'll have x is now less than negative 6 over negative 7. The two negatives will make a positive, so 6/7. So that's solved. Now I want to draw my graph. So that's a number line. Our boundary point is 6/7. Since it's less than, I'm going to be shading to the left. So it's everything to the left of 6/7. And since it does not have an or equal to sign, it's going to be a parentheses. Or you can draw an open circle if that's your preference. So there's my graph. Now I want to write my solution set using interval notation. So it goes all the way to negative infinity. And then on the right, 6/7 with a parentheses because there's no or equal to. All right, my last example, number 4, trying to get the x by itself. So probably the easiest thing to do here would be to get rid of the fraction first. So since we're dividing by a -2, I'm going to multiply both sides by a -2. Since I'm multiplying by a negative, remember that is going to change my inequality symbol. So the -2's would cancel on the left, and I would have -3x plus 5. I'm now going to have a greater than or equal to, since I multiplied by a -2, -8. And now just continue solving. So subtract 5 from both sides. That'll give us -3x is greater than or equal to -13. Divide by -3. And so x is, now we have to switch it again, less than or equal to, because we divided by a negative, 13/3. And so it's possible that you will flip this inequality sign more than one time when solving. So every time you multiply or divide by a negative, you're going to flip it on that step. So there's our solution set, right? We've solved. If we want to use a graph to represent our solution set, we put our boundary point on there. We're going to shade again to the left because it's a less than. We're going to have a bracket or a closed circle because it has a or equal to sign. So there's our graph. And now our interval notation will be -infinity to 13/3 with a bracket.